Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us move to another question number 4 of gravitation based on Kepler's law. Students, let us solve question number 4, which is based on Kepler's law. That is, let me just explain the question in the form of diagram. This is there's a path along which the planet is moving, that is elliptical path. According to Kepler's law, the path is elliptical, and this is the major axis and this is the minor axis of the ellipse, and two focus, one is here and is here. Suppose the sun is here at any one of the foci. Suppose that this point is called the aphelion or apogee, and this is the perigee or perihelion. Okay, so I write this is apogee, and this point is called a perigee. So this is a perigee. Actually, this is perigee, and this point is called apogee. So suppose I call this A and this point as B, then B is your perigee and A is for apogee. Okay, now it says that the planet is moving in this way, and I'll name this point as also C and D. The sun is here. So it says that the speed here is suppose moving like this is VA, and the speed here is VV. Obviously the speeds are not same. That also we have to establish which point A or B the speed is more. That is the first question, and which area. So when it moves from we have to say, if I join this point with this one and sun with this point, then when the planet goes from D to C, the right side here and left side here, whether the time taken is same or not. That means first question is find the relation between VA and VB. That means relation means which one is greater and which one is smaller. The value you can find. Find the relation between VA and VB, which one is greater. And second point is you have to find the time T from D to DAC, this time, and the time when it comes from CBD, what is the relation, whether it is greater or it is less or is equal, that you have to justify. So here also VA is greater than VB or less than VB or equal to VB. These are the two questions you have to answer. So the question is that the planet is moving, and when it is at apogee, what is the speed, whether the speed is greater than the speed at the perigee, and when the planet goes from D to C, then how much time it will take, and C to D again by this path, whichever time is longer or they are the same time. So this is the question. Now we will solve the question. Solution. We know that suppose the planet is moving in the sense anti-clockwise. When it moves from we have this motion of the planet is based on the principle of conservation of angular momentum. So principle is conservation of angular momentum. If you apply conservation of angular momentum at A and B, at A this distance, when it is at here, this is the distance, this is the radius, I will say, this is R A, I say, and when it is here, this distance is RB. And the mass of the planet at here and here will be same, so mass will be m only. The angular momentum is mvr, at these two positions because it's 90 degree at MVR. So MVARA for this position is equal to, for this position it is MVBRB. M is the mass of the planet being same at all the positions, so I'll just cancel that, and this distance is clearly seen that it is greater, this distance is greater than this distance because this is the apogee and this is the perigee. Perigee is a smaller distance from the sun. So I'll write that because if I take the ratio, then VA over VB is equal to RB over RA. But now RB over RA is less than 1 because this is smaller and this is greater. So this is less than 1. So because RB over RA is less than 1, because RB is less than RA, so the ratio that we got, VA over VB, which is RB over RA, because this is less than 1, so this factor also will be less than 1, VA over VB will be less than 1. That means VA is less than VB. That means the speed at apogee is less than the speed at perigee. So that means when the planet approaches sun, when it is more near and near, the speed is more and more. So at this point, this is the maximum speed it can have, and this is the minimum speed it can have here. So this is the relation that we got, that VA is less than VB. So this part is clear that this less factor is correct. Now coming back to the time taken, then for this we have to think of Kepler's second law, which talks about aerial velocity. Aerial velocity is that the planet sweeps out equal area in equal interval of time. Equal area in equal interval time, that means that this from here to here, DAC, the area swept by the planet with respect to the sun is this distance. This is the area swept. This much will be the area. Okay. So this area is obviously looking greater than this area. Which area? This one. The remaining part you can see here. This area is smaller. This area is a little smaller. So this area is obviously more, so it will take more time. So that means we'll write that the time taken for this greater the area, greater the time. So this will take more time, and this will take less time. This area is more. So as area is more, so this time is more, so DAC time is greater than TVC. So I can write that for second part of the question, the time taken at the DAC is greater than the time taken for the CBD, because the area in case of DAC is greater than area in case of CBD. Okay, so this is the answer to this question. Thank you.